Now we're going to be talking about square root addition or subtraction. Square root addition and subtraction. So if I have an expression, for example, 2, if I say add 2 times the square root of 5 plus 4 times the square root of 5. Notice that we have the radical parts are the same in both of the things that we're trying to add, right? They're both square root of 5. And from what we know about factoring, that's almost like saying, well, we can pull out, actually it's exactly like saying, we have the square root of 5, and on the outside we have a 2 plus a 4, so that's really 6 and the square root of 5, and we'll write that as 6 times the square root of 5. Okay? But again, it's only because the radical part is the same. If I said add 2 times the square root of 3 and 7 times the square root of 5, this is as simplified as it gets. I can't add them anymore because these two aren't, the square root of 3 and the square root of 5 can't be simplified any further. However, let's take a look at something else. If I ask you to simplify 2 times the square root of 50 minus the square root of 8. Now at first glance, what's under the radicals aren't the same, right? But if you remember, these two aren't simplified because we actually have perfect square factors inside. So I can rewrite 2 times the square root of 50 as 2 times, and 50, remember, is 2 times 25. And 25 is a perfect square factor, right? And then 8, I can rewrite it as 2 square root of 2 times 4. Okay, so now if I look and I know how to simplify my square roots, the square root of 25 comes out as a 5, right? And the square root of 4 comes out as a 2. So here I have 2 times 5, and the 2 stays in here. And over here, one of the 2's comes out, but the other 2 stays in. So I really have 10 times the square root of 2 minus 2 times the square root of 2. And now if I look, I have the same radical parts. Right? So it's just like when we talked about simplifying terms, you had to have the same variable parts. Here we have to have the same radical parts. So now I can simply take the quote-unquote coefficients out front, right? The numbers out front. I can just have 10 minus 2 times the square root of 2, or 8 times the square root of 2. Okay, so if you look at the example up here, we can't simplify these anymore. Right? We have no perfect square factors that we can pull out, that we can factor 3 or 5 into. But 50 and 8, we could have factored that out a little bit more. Let's try a couple other ones. If I have simplified 4 times the square root of 72 minus the square root of 18. Again, I don't see, I see that these two aren't perfect squares, but I notice that 72 can be broken down into 2 times 36, and 36 is a perfect square. Right? 72 can be factored into 2 times 36. 18 can be factored into, think of a perfect square factor, 9. Right? So if I take the square root of 36, I'm going to get 6. So that's the same as 4 times 6, and inside stays that 2, minus the square root of 9 comes out as a 3, right? The square root of 9 is a 3, so 3 times the square root of 2, the 2 stays in. And now I have 24, square root of 2, minus 3, square root of 2, or 24 minus 3 times the square root of 2, which will give me 21 times the square root of 2. And that's as simplified as it gets. So far we've been working with 2 terms. We could also add or subtract 3 terms. So let's try, as an example, I have simplify. 8 times the square root of 2 minus 3 times the square root of 72 plus the square root of 8. Again, I have 3 different pieces, right, of this expression that I can break down. This one, 8 times the square root of 2 is done. I can't, there's no perfect square factor in there. I can't do anything else with that, so I'm just going to rewrite 8 times the square root of 2. Minus, when we have just done, 72 can be factored into 2 times 36, right? And we know 8 can be factored into 2 times 4. So I'm going to bring down this 8 times the square root of 2 still, since that doesn't change. But my 36 can come out, right? The square root of 36 is 6. So that's 3 times 6, and the 2 stays inside, plus the square root of 4 comes out, it's 2, and this 2 stays inside. So I'll have 8 times the square root of 2 minus 18 times the square root of 2 plus 2 times the square root of 2. And again, because I have the same radical parts, I can just think of this as 8 minus 18 plus 2, all times the square root of 2. Or if I add these, I have 8 minus 18 gives me a negative 10, plus 2 gives me a negative 8 times the square root of 2. Okay? So that's how we work with numbers under the radical. We can expand on that, and now we're going to have variable expressions inside the radical. So let's take a look at what we have here. If I said simplify the square root of 63x minus the square root of 28x. Well, remember what we said before. We can look to see if we have any perfect square factors again. Right? And if I look at 63, I can break that down, factor it out as 7 times 9x minus, and 28 I can do something similar. I can have 7 times 4 times x. And if I look at these, I have perfect square factors, right? 9 and 4 are both perfect square factors. So the square root of 9, 3 comes out, and I'm left with 7 and x that stays inside, minus this 4 comes out as a 2, right? Square root of 4 is 2, and I also still have a 7 and an x inside. And here I can combine them, again, because the radical parts are the same. Oops, so that should be 7 square root of 7x. And out front I have 3 minus 2, which is just 1 times the square root of 7x, which I can just leave as the square root of 7x. Just like everything else we've done, we're going to add just a little more complexity to this. So if I said simplify square root of 75 z squared cubed plus 7z times the square root of 48z. All right, and again, just like every other problem that we've done, we just break them down into smaller problems that we can handle. Right? So if I take a look at this radical expression here, I look for my perfect square factors. And 75 is 3 times 25. Fortunately, 25 is a perfect square. Right? And remember, anytime I have a variable with an exponent, if the exponent's even, it's a perfect square. But if it's odd, I can make it an even exponent. I can make it z squared times z to the 1, right? Because if I use my exponent, my product rules, 2 plus 1 gives me 3. So I'm going to rewrite it that way. And then over here, I already have a 7z on the outside. And for this radical, I'm going to have a perfect square factor. 3 times 16 gives me 48. And I can't really do anything with that z, so I'm going to leave that in there too. So now looking at my two looking at my two radicals, I see that this 25 and the z squared are perfect squares, right? And over here, my 16 is a perfect square. So those are the ones that can come out, right? The square root of 25 is 5. The square root of z squared is z. So this gives me 3 remains on the inside, and a z remains on the inside. So I have 5z on the outside of the radical, and inside I still have 3z. Plus, I have 7z on the outside. I take the square root of 16 and I get 4, so I can multiply it by 4. And on the inside I'm still left with a 3 and a z. Okay, so I have 5z times the square root of 3z plus 7 times 4 is 28. So I have 28z all times the square root of 3z. So this is good, right? My radical parts are the same. 3z, and I factor that out, and I have 5z plus 28z. And since these two are like terms, I can add them together. And I have 33z on the outside and 3z on the inside. Right, notice that these two had to be the same like terms as well, because otherwise I couldn't have combined them, right? One thing I want to make sure you recognize with the addition of radical expressions, if I take something like the square root of a plus the square root of b, that does not equal the square root of a plus b. Okay? Exclamation point. Please do not do that. You cannot combine this because they don't have, they're not like radical terms. Okay? So square root of 5 plus the square root of 6 does not equal the square root of 11. This is very, very important. So I don't ever want to see any of you do that, okay? So remember, unless these are alike, unless the radical terms are alike, you can't just add the insides. So I'm going to leave you with that thought, and then we'll talk about multiplying and dividing radicals.